Welcome to Digital 360 Summit 2020. We are the premier event for senior executives driving industry digitalization, decentralization, and decarbonization. 2020 edition is a free virtual event via Zoom. The dates are August 18th, 19th, and 20th, 2020, and August 25th, 26th, 27th, 2020. We want to thank our sponsors, Texas State University, Greater San Marcos Partnership, and Cedar. This year's edition has 70 speakers from amazing companies like NASA, Intel, SAP, CPS Energy, Brazos River Authority, Katerra, Direct Energy, City of Austin, Aclara, Dell, Engie, Exelon, Oracle, Tesla, General Motors, TXDOT, Vistra, Siemens, AT&T, National Grid, Itron, City of Los Angeles, Austin Energy, City of Colorado Springs, and Hunt Energy Network, and over 1,000 attendees. The program has 16 keynotes and 11 panels, followed by 11 white papers and 28 videos. The event covers multiple industry verticals like networks, energy and utilities, buildings and infrastructure, water and wastewater, public safety and new financial tools, smart cities, sensor and edge computing, big data and software, smart mobility, new regulations and business models, space and smart factory, and Industry 4.0. We are also introducing Texas State Cedar, a new industry research consortium focused on connected infrastructure research enabling big ideas and the topics covered in each of the panels. We at Texas State, Star Park, Cedar, the Greater San Marcos Partnership, and industry partners are focusing on building 9 living labs to transform applied research and economic development with the goal to delivering one digital world.
Welcome to the Smart Buildings and Infrastructure panel. And as we saw in this introduction video, and we're delighted with the phenomenal panel, I want to share real quick before we get into the keynote where we are heading with Cedar and our really opportunity to share the future of information and research as we see it. And real quick, there we go. Before I find it. So if you let me show you this video, which I'm going to make big now, and this is what Cedar is about, and John in the panel will talk about it and peripherally as they start their session. Well, thanks for being here. Let me introduce you to Pat Meagher, who is a principal at CMG now, formerly just about a few weeks ago with Katerra as VP of Technology and also a former executive with Flextronics. And we're delighted to have him to share his vision of the future of building infrastructure, smart technologies applied to all that, and where the future of construction and consumer electronics collides with apply intelligence, AI, machine learning, and all of the above. Pat, thank you for being here.
Thank you for the kind introduction, Andres, and I'm delighted to be here and happy to share some of my thoughts and experiences with the panel and the folks that have joined the webinar. So
before you get rolling, let me say hi real quick to the whole team real quick. John Schemmel, hello, how are you, sir? And Alper, how are you?
Good, thank you.
Jay.
Hey, Andres, how you doing?
How are you? And Sunil.
Doing great, Andres.
All right, Scott.
How are you doing today?
Excellent. You as well, I hope. And Rebecca, how are you?
Great. Happy to be here.
Excellent. Excellent. Well, with that said, guys, I'm really honored and proud that you're here. And Pat is all yours.
All right, let me share my screen here with the. All right, hopefully everybody can see my screen. It's the first level of business for smart buildings is to be sure we can enable technology in these days and ages. So hopefully that's good. And I want to start off by just a real quick introduction of my background. So I'm really a technology and a product development person. I'm not an architecture or engineering construction type, but I think as Andres had said, these worlds are colliding and they're colliding fast. So I'm here today to talk about smart buildings and infrastructure, what that means. So I thought first we would start with some real basic ideas of, what is a smart building or infrastructure? And you can see that, even from the beginning of time, buildings were mainly provided for us to have a comfortable and safe, living and workspace for the people inside. And at our most fundamental level, smart buildings are ones that can help us deliver, information and services that make our lives and our work lives more productive at the lowest cost, and certainly with the environmental impacts in mind as well. You think of a building and there's lots of different features, lighting, thermal, HVAC, air quality, physical security, sanitation, et cetera, et cetera, et cetera. So I think reaching this vision really requires adding intelligence from the very beginning of the design phase all the way through the end of the building's useful life. And so I'll talk about that a little bit too. You can see that that it goes really way beyond the four walls that are inside the building today. And I think also a kind of a funny thing as buildings become smarter and infrastructure becomes smarter, people that used to stand in the corner and talk to the walls were thought to be crazy, but pretty soon I think most of us will be doing that, surprisingly enough, right? So connecting these buildings really is connecting the people through the technologies to things like smart grid, and really enabling our ability to create an intelligent future and fulfill the intention of what the buildings were intended for. So technology is a key piece of this, right? And the next slide to me is kind of a, an experience that I've had over the past couple of years. You go, what? Technology in the AEC industry, that has not been really the norm. If you look at productivity and GDP charts over many, many, many years, AEC has been lagging and potentially even negative productivity in this industry for a very long time, which is surprising and shocking. Most other industries, actually all other industries, if you think of aviation or industrial or automotive, have heavily leveraged technology to achieve the productivity gains and efficiency, cost benefits, and all those things that you would expect that you need to be able to be improving. You look at the web, and I found many, many, many charts, and they all kind of look the same. Yes, two are represented here, one out of Stanford and one off the web. But if you look at this industry, it kind of creates this sort of less than inverted V sign, where the AEC productivity is actually very low and even negative over many, many, many years. And you can see some of the other what they call non-farm or industrial, wholesale, energy, certain other businesses like that have had significantly increased GDP as a function of being able to leverage technology. Being able to do that is actually essential for what we need to do in this business today. And you think, technology adoption also has to help some of the largest problems that I think the industry is seeing today. So there's very severe skilled labor shortages that affect the ability to execute projects. There's a tremendously large gap in affordable housing that's obvious today, and there's lots of data around that. But the industry has very low margins, so it makes investment in technology very difficult. And of course, projects as we know them today, are becoming mega projects. They're super large. They're very complex. There's a lot of supply chain issues. There's a lot of scheduling issues. Buildings that are large have a lot of people. They have businesses and services and transportation, so on and so on. So it's imperative that we do this. And the reason why is because smart buildings will actually touch every aspect of our modern life as we go forward. As I go through this, to just make a few notes, it's like, today, most buildings are very dumb. In fact, probably 99% of them are. And it's going to take a lot of effort and a lot of work and a lot of capital to transform. But I think it's an imperative. And the reason why is if you look at this, what I call maybe the application layer, it is literally going to touch every aspect of our life. And we need to sort of expedite and move this along. So if you just look at the boxes, efficiency, there's impacts on energy and utilities and lighting and water usage, HVAC and air and gas quality, all of which are important. The people that occupy, buildings and homes, enhanced convenience, enhanced communication, everybody's leveraging, social media and entertainment. Food services are changing. Our life even today, think about the pandemics that we're in now. This has dramatically changed our lives around, social distancing, antibacterial surfaces and concerns about that. And also things like Zoom that we're on now, where we are sharing more and more virtually than we are even directly. So lots of impacts there. On the safety end, things like fire, earthquakes, terrorism, which is obviously a global concern, floods, natural disasters, and the ability for buildings to respond to those things and help direct our lives in a way that we haven't seen before. Certainly mobility, as EVs come online, charging and use and ability for that, advanced transportation technologies, the Uber has kind of become the norm now, where you can, literally get a ride based on your phone. Parking and accessibility is increasingly important in dense urban environments. And finally, sustainability. This is really important, where smart buildings can help to enhance the ability to maintain, go from, maybe reactive scheduled maintenance to predictive maintenance and repair. Things like waste management, durability of the building itself or life cycle, and of course the renewables. So it will touch every aspect of what we need to do. So I'll just give a few examples here. If you look at both like building operational elements and then external information interfaces, the whole building automation system will help work across the 5 boxes there on the application layer. Certainly utility data, security and proximity is increasingly important part of our lives for all the reasons I stated. Fire, HVAC, energy and smart grid sustainability and usage is critical, I think, moving to the future. On the external information, I touched on social media, certainly weather, work environments and exchanging of business data, and certainly mobility and transportation are all very critical parts of our lives now and need to be embodied increasingly in the buildings that we live in and occupy to help bring efficiency and value to our lives. There are so many technologies and deep pieces, I think, that are related to smart buildings and smart cities that, I will only be scratching the surface here for sure. We do have some more detailed, deeper dives on these. I think the smart network one was yesterday based on this slide. And then we've got sensors, edge compute, and big data coming up here. But I wanted to highlight what I think are 3 fundamental technology enablers for smart building and smart infrastructure. There's many more, but these 3 I think stand out. So the first one is this idea of advanced data and communication networks. The sophistication of these networks and the ability to share information is going to be pushed really to the limits of what the current networks can envision. And they need to seamlessly communicate and operate really reliably from very small distances, maybe a few feet, all the way to global connectivity. And so what happens is you've got solutions for each of these that are very well known in advance, as I've shown here, as you sort of grow the network, if you will. There's the BLE 802.11, Bluetooth Low Energy for very close communication proximity, maybe 2 to 10 feet. Then you go into Wi-Fi or WLAN, maybe 500 to 600 feet. LoRa is a emerging technology, sort of multi-campus, campus type thing. Obviously 4 and 5G are widely in use and widely deployed, and so is satellite. But what you're going to find is that, if you think about some of the things that we talked about, and I've got to trigger a sensor in a building, for whatever purpose, and it's a local event, proximity, and then I've got to get that onto a larger network, a 4G or 5G, in a way to push the information or pull the information or present the information to whoever may be affected. There's a lot of upgrades and sort of seamless interfaces that I think need to continue to evolve to do this. So there's all these technologies are in play, and there's many. Each of these could be a deep dive on its own. But suffice it to say, in order for smart buildings and smart infrastructure to exist, the network is going to have to dramatically expand and improve. So I want to give an example of what this could be or what this could look like, right? And if you think about infrastructure today and how could you implement something like this? Well, lighting systems are nearly a ubiquitous part of our current infrastructure. You look around, lights are everywhere. They're in buildings, they're in parking lots, they're on roadways, they're in malls and businesses, and you name it. And then also with this, the advent of LED lights is also causing a big change out in this piece of infrastructure. So this is unique. Your lights have been around since the dawn of time, just like buildings have. And it's, maybe gone from incandescent to CFL, but it's now really a wholesale shift to LED. And the benefit of LED is obvious. It really does use less energy to create the same amount of light. So there's a real advantage to that. But if you start thinking about lights are being changed out to LEDs, then there's many technology integration opportunities where you could start to think of a comm network really as what I call a massively distributed mesh network, or MDMN, as I'm so fond of making acronyms. So you could literally say, wow, if that's happening, I could create networks that could, for example, make nodes. The node 1 is shown as maybe like a roadway. There's roadway lights that are every 200 feet along a roadway. Wow, there's lots of them. Park and recreation areas, there's lots of green spaces in the world. Parking garages, wow, every building has a parking garage. So if you treat those as a node and start to say, if I've got these nodes and I need to interface this within the light systems, I can create basically what I call like a hockey puck. The hockey puck could have processing capability. It could have camera and video elements, and it could have storage elements in the puck. Today you can get, the latest thing I look, you get a terabyte on a thumb drive for, $80 or something like that. So you could put hockey pucks in light systems in each of these nodes and very simply connect them, through the gateways and the existing IP backbones into the data centers. Quite a few of the parking garages and things are, pretty much co-located, with the central office and where all these servers are. So what happens now is the network edge can become hyper extensible and recreatable as an overlay and provide very easy, core network connectivity. This is just an example of an architecture that you could use to do that. But if you start to think about that, now I can actually create very powerful network overlays on top of the existing, data center and IP gateways and central offices that are already there, that could potentially very easily be extensible to handle, terabytes and terabytes of data information and, billions, potentially billions of sensors and more users, to a network like this. So if you look at technologies like this, is actually very exciting. And, and it's an overlay on what has typically been a, pretty stable, non-performing, mundane business, around constructing buildings and cities. So the second piece and these are all closely related, for sure, as you look at this. The second piece is what I would call like sensors and edge processing, right? So again, I'll give some examples, but there'll be sensors that will become ubiquitous in our life around just about everything related to the 5 application layer pieces I talked about earlier. They will go into gateways, and the gateways will actually become powerful edge processing elements, because a lot of the data and what you do will have to be, sort of generated, stored, and managed on the edge before it's actually put, into any kind of central office or anything like that. So as an example here for that, I'll give you some simple examples around really how you would sort of instrument or sensorize a building for some basic functions. So 3 are shown here. One is like, vibration within a floor is important for occupancy and use insights, for acceleration, for noise creation and management, which will all become important. Sensors can also be used for moisture content, which could be overtly like floods. Floods are very damaging to buildings, whether localized or whether widespread. But maybe you can, predict or collect information about a leaky sink or a leaky toilet that might go undetected, for months until it does a lot of damage to the building. Foundation accelerometers that can measure seismic responses and feedback, or basic building durability elements over time, I think will be important to the life cycle of the building. Roofs for loading and deflection, windows and door sills for all types of things. Windows are becoming very sophisticated around sort of electrochromatic darkening to provide all kinds of HVAC and thermal load controls, quite possibly even being used for things like whiteboards. Proximity is going to be important. People coming and going from a building is going to be paramount to security. And then also kind of a rehash, but moisture, flood, and event notification can all be built into sensor systems that can be passed into gateways and managed for the information flow. The third piece, which we have a whole deep dive on this, and this is a whole vertical in itself, so I won't spend a significant amount of time on this, but one that's very important is obviously the cloud services and data management. So if you think about this, there's a lot of sophisticated AI, ML algorithms that are under development to help determine what to do with the sort of the massive information flow. Is it an act now, act later? Is it a forward? Is it a store? Is it a control? Is it an alert? All these different things, you have to parse that information real time, based on events or requirements, and then figure out what to do with it in the cloud. And each of those could, they represent different challenges around how you process the data streams, what the state recall, elements are for any of the sensors. There's all kinds of cloud services that can be developed there, and there's purpose-built apps around that. And in fact, when you think about this, there's this whole idea of, in telecom, I'm a telecom guy from way back, but there's always a network operating center, a NOC. And really that has all the command and control features, which have now sort of been replicated in the cloud. So I could imagine that, building owners, city governments, homeowners associations might even start building virtual NOCs in the cloud to manage, manipulate, store, and act on the information that can be generated by a smart building or by a smart piece of infrastructure, again, to create value and create benefits for our personal lives and things like that. So also, I think that once you start looking at these things, and this is a lot of the work that I've been doing here recently, is if you look at the far right of this, if you can see my cursor, most of what I talked about is beyond the right of this slide. Once the building is finished, it goes into the full life cycle. But if you think about the way companies are thinking about building buildings and cities today with this idea of prefabrication or modularization, all these networks and systems go all the way back to the very beginning of a building during its design, because today we're thinking that, wow, just like every other product, every airplane or car that's manufactured, or even cell phones for that matter, are fully parametrically 3D designed with bills of materials and parts and supply chains that are already pre-designed way before you get to the factory, much less to the user in the field. A car, every single nut and bolt and wire and brake pad and you name it is in a 3D model. It's been designed, it's been validated, it's been analyzed. There's a very sophisticated supply chain associated with that. Well, guess what? The same thing will be happening to buildings in cities, where they will start to be created exactly like products. They will be created in factories, and they will be assembled on site instead of construction, the way that we do things today. And so when you think about all three elements that I've been talking about here, advanced networks, sensors and data, and huge amounts of data management, that goes all the way back to the beginning of a building design today, through the use, as everybody knows, of digital twins, which is becoming a very effective way of doing a building design. So it can touch every element of the design process, the production, documentation, change management, quality data in the manufacturing, traceability of materials, factory production, scheduling, and yield data. You guys can read all these. I don't just want to read off the slides, but if you look at this, it really starts to touch every element of a design and build process that we can now map to the construction industry to create smart construction, smart extended job sites. The job site will start to look like a factory itself, to result in a finished building that's done faster and at a cheaper cost and at a sort of scalability and reusability that's never before been imagined. Okay, so like anything, we're for sure faced with the difficulties of actually making this happen. And I always like to say, this isn't my own thought, many people have this thought, but for sure the adoption of anything new in life is hampered by this tension between the status quo, and there's a huge status quo in place, obviously, for this industry, the need for innovation and the requirement for return on capital. So the barriers are very high for this, and that, I think, is what's causing some of the lagging adoption, but I think there's many ways that we can start to overcome that. And that's an very important thing that exists anytime you try to disrupt or change or improve something that's been around for a long time. Also, smart buildings need smart integration, right? Just because these technologies exist and you can buy them doesn't mean that you can buy them and stick in a building and all of a sudden I have a smart building, right? It requires extensive integration, and the integration of those things and the manifestation of all the three key pieces I talked about is expensive and challenging, right? So we've got to find a way to actually deal with that and overcome it. There's also many policy implications at local, state, and federal level around, incorporating technology, both in the work base, in the municipality, in terms of licensing and regulation and permitting and things like that. So there's a lot of considerations there. And then smart building infrastructure technologies also require extensive modeling, testing, and verification to be able to calibrate the impacts on electricity and vehicle infrastructure, energy uses, et cetera, in order to enable basic adoption. So I think that back to Cedar here, so colleges and universities have a big role to play in this. And I think Texas State is a great example. I realize they're our sponsor, but I'm fully bought into the idea that, like the Cedar opportunity that we'll spend lots of time talking about, implemented by Texas State, is really a way to accelerate this. It allows us to sort of adopt and align curriculum to support the technology convergences. It starts to prepare engineers and workers for the future of this industry with technologies that are maybe non-traditional, and they're creating co-op programs to work with industry partners to help accelerate this. And what I found particularly interesting about Cedar, even way prior to creating this presentation, their Cedar sort of infrastructure is based upon the 3 layers at the bottom are exactly the 3 layers that I think are the key things to be able to make this work out in the way that it needs to. So networks that we talked about, sensors and data, big data, big software. So that's really quite an amazing outcome. And I'm very happy to be associated with Texas State to help accelerate this. I think this is a key way of breaking through some of the challenges and getting the ability to actually have these things manifest themselves, in our building in a much more expedient way. And then lastly, just a real quick pitch here on the 360 Summit. I think Andres and the team at CMG have done an amazing job, gathering industry experts like ourselves to create the dialogue and the presentation and the sharing of information to let, all sorts of manners of the ecosystem that's involved in this to know what's going on, to share thought platforms, extend technologies and ideas to really move into a transactional mode where we start to do this. And this is quite a extensive and storied group of folks that you need to get together to make these things happen. So very, very proud to be part of CMG and Digital 360 to help do this. And I think with that, John, I'm probably just about out of time. So I will stop here and hand this back over to the panel for further questions and discussions. Thank you all very much for the time and for taking the moment to listen to what I had to say.
Thanks, Pat. Andres, I didn't know if you were going to chime in here at all. And if I don't hear anything from you or you don't chime in, yep. Did you want to say anything before we move to the panel, or
just thank you, Pat, for a fantastic keynote and way to tee it up. And John, I'm very proud to be working with you, and thank you for bringing me on board here at Texas State, and take it over.
All right. So one thing I'll comment on, there's been questions come through, and I see that there's some activity in the chat. So we're going to have comments from the panelists next, and then we'll have a Q&A session at the end. So feel free to write in the chat or to send a question, and we may answer it during this time, and we may get at it at the end. So for efficiency, I'm going to have all the panelists actually introduce themselves. Take a moment to do that, and then I'll have some questions for the panel, and we'll hear from them in more detail. So Alper, if you wouldn't mind starting off the self-introductions, I'd appreciate that.
Yeah, I'm the founder of Anka Labs. We are in the smart building space, creating edge analytics controllers and sensors.
Hi, I'm Jay Zoellner. Yeah, sorry, John. First of all, thanks to everyone for having us here. I'm Jay Zoellner. I'm the CEO of Kiwi Power. We are the #1 provider globally of virtual power plant technology.
And you're in London.
And I'm in London, yeah, it's great. It rained all day today and it's late now, so.
What a surprise about the rain. Rebecca.
I'm Rebecca Davio, and I'm here in San Marcos, Texas. As you can see, I'm associated with Texas State University. My primary job there is I'm the director of the Institute for Government Innovation. I am also an associate professor of practice, and I teach a solid waste management and recycling class.
Scott, you're up.
Hi, I'm Scott Hinson. I'm the CTO of Pecan Street. We are a 501c3 nonprofit based in Austin, Texas. We primarily our sort of claim to fame is that we collect information from behind the meter data collection systems, measure energy at a 1-second interval basis. So we collect about 2.6 billion data points a day on how people are using and generating energy, and we turn that those measurements into test beds for folks to deploy experimental virtual power plant systems, demand management, demand response systems, energy storage systems, things like that, and we have the means to understand how those systems interacted with the real world.
So real quick, can you give 30 seconds on what Pecan Street is? I mean, like, what does that mean, Pecan Street?
That is probably one of the more unfortunate naming things. That is the old 6th Street on old name for 6th Street. We still get calls. It's down this year with COVID, but we still get calls with people confusing us with the Pecan Street Festival, and they want us to throw a party for them, and we're like, that's not what we do.
This is in Austin.
Which is also in Austin. But yeah, so the name originated from a community organizing project that was, started what, 12 years ago, something like that. It was involved. I mean, there's a whole bunch of folks involved, and the name kind of stuck. And in some ways we love that, and in other ways it's really kind of annoying.
I'm going to come back to you on Sunil.
Thanks, John. And,
yep.
Hi to all the panelists. Great to be here, and all the attendees. I'm Sunil Cherian. I'm the founder and CEO of Spirae. We basically build control software for microgrids and hybrid energy systems. And we'll get into that a little later. We're based in Fort Collins in Colorado, and we do projects in the US. We've deployed projects in Africa, in the Middle East, more and more so in Southeast Asia. But essentially our claim to fame is basically integrating any type of distributed resource as a microgrid and delivering services around that.
So you need to slide a little bit over to your left because you're blocking your logo. So, wait, there.
Got to figure out which way to move on that.
Yeah. So I want to go back to Scott just for a real quick second. Are you planning a headbanging concert after this, or what's the deal with it?
I work these days out of my garage most days, and I have a side hobby of PA systems, and I prefer to measure my audio systems in horsepower. It's a more convenient measurement than watts.
Okay.
And this is a 30 horsepower system sitting behind me. So we could reach out and touch, 4,000 of your closest friends if you really need to.
Okay. It makes me think of the old days when I was a kid, and that was the standard in your house sound system, right? All those speakers like that. So
somebody asked me the other day, does it go to 11? And my response was, this is 11.
So I will just do a quick intro for myself. John Schemmel. I'm a professor at Texas State with the civil engineering program, which launched last fall with the first class of students. 97 students enrolled in the program, where we were predicting a little under 70, so that was great. We're already at 120 students enrolled in our introductory class for this fall. So I'm hoping that we'll be somewhere in the 250 range of students enrolled in our program come the end of the year. And if you're not familiar, we are focused on technology enhanced infrastructure. So this panel actually is near and dear to my heart in terms of the topics and other ones that are a part of the program here as well. So we're going to hear from the panelists now, and I've got a series of questions for them. So they're going to take some time to reflect on Pat's comments and introduce some new thoughts of their own. And then when we've gotten through everybody, then we'll open up things to Q&A from everybody that's participating in the session right now. So Sunil, you're going to be up first. We're talking about infrastructure here, not just buildings, but infrastructure, and energy is a big part, represents a big part of civil infrastructure. So can you comment a bit on the development of grid edge energy resources, where we are today with their implementation?
Absolutely. I think Pat did a great job sort of laying out the various things that are coming into play when we talk about infrastructure, building infrastructure systems, and infrastructure in general. And energy, of course, is a big part of that infrastructure. Historically, when it comes to electricity, as all of us know, it was produced somewhere far away and transported to you, and you flip a switch and there you go. What's changing, or what's been changing in the last say, 15 to 20 years is that a lot of the technologies have been moving closer to the consumer. So whether it's a solar on your rooftop or an EV in your garage, that set of technologies are now getting smaller and connected at the edge of the grid. And when it comes to a building, for example, a lot of the infrastructure can now be localized. So this is really the opportunity that we are seeing today. And when we talk about grid edge energy resources, it's really about what these resources enable relative to how things were before. Just one quick example, if you think about electricity being produced, from mining fossil fuels somewhere far away, burning it, producing steam, converting to electricity, bringing it all the way to your house, turning on a light and reading a book. And then if you look at the energy that's actually goes into, allowing you to read that book versus all the energy that was wasted along the way, it'll be, some of you might know this, but it's a shocking to realize that less than 1% of the total energy expended really is required to read that book. So the moment you localize resources, like for example, you have your solar on your rooftop and a battery in your garage, the efficiency gains that you get is just tremendous. And you apply this across the board, that's the type of thing this energy resource localization can actually achieve. The second issue that comes into play is what I call energy personalization. So, if I may want 100% renewable energy, or I may want the lowest cost electricity that I can possibly buy. That view would be completely different for my neighbor. They want something different. Maybe they want a net zero building or something else. So this ability to personalize energy services is now coming into play, right? So far over the past, 100 years, it's been a kilowatt hours game. It was the absolute commodity. Electricity was the absolute commodity. The ability to personalize energy services using grid edge resources is a big enabler for dramatic changes going forward. So it's not just about the solar on your rooftop. It's the fact that how I utilize energy or the benefits that I'm looking for can be different for my neighbors. And service providers can now differentiate their offers quite substantially, something that they've not been able to do in the past. A side effect of this, of course, is decarbonization. So, so these things are all coming together, and I think that's what's changing the view of infrastructure, this concept of localization, personalization, and decarbonization being enabled by distributed energy resources. Now the question is, if this is so great, how come the adoption is so slow, right? That's all of us can ask that, and say, we've all been in this business for at least 20 years, and we're still talking about all of this being 3 years away. So one of the biggest issue that we deal with is, as we start assembling all of these technologies, and again, since I don't have slides, I'll refer to a Pat slide that he presented. When you look at the number of technologies and all of the things that have to be assembled, and the fact that it's an architecture, construction company that's putting this all together way up front, and it's a cookie cutter process to actually build this process. When it comes to energy, a similar thing is happening, right? You have sort of design build approaches to actually putting hybrid systems together. And what's really going on is that you're taking technologies that have worked well for large systems and trying to apply it to very small systems. And you really have enormous amounts of engineering costs that are actually buried in it. What we consider going from concept to operations. Everybody complains about the cost of a battery, but the fact is, the cost of the hardware is probably less than half the cost of a deployed project. All of those other costs, from engaging a customer to figuring out how to design a system that works for them, deploying it, commissioning it, and making it work, is a very challenging exercise, especially when all the components are coming from different vendors. So so that's the situation, and that changing that dynamic is actually quite complex. And the opportunity is to actually make a difference there. If you can actually make a difference there, then I think adoption can actually scale much more rapidly, from buildings to communities, to campuses, to smart cities. A lot of this is a very fundamental problem. So the way in which Spirae is approaching this is to really look at, how do you standardize these approaches? How do you make these systems, configurable? And then very importantly, when it comes to different types of equipment, how do you make them as close to plug and play as possible? So you want to be able to buy an inverter from anybody. It shouldn't matter. The battery system can come from whoever. The use cases, however, are somewhat limited. And if you have half a dozen use cases that customers are interested in, you should be able to plug in any of this and actually enable that. So if you can do that, then you are actually changing the equation. And I think now we're close to being able to enable that. And in Spirae's case, there are sort of two pieces to the puzzle. One is a cloud platform that allows, as we say, to go from the concept to configuring systems to supporting deployment and providing the tech support. So that's really a sort of a workflow management piece, if you will. And then you have the control software that has the smarts to actually plug in and work with anybody's equipment to deliver specific values. So that's the approach that Spirae is taking. And we believe that all of this really comes together at these different levels, from buildings to campuses to cities, as I was mentioning. And I think those are the values that are being opened up. And I'm sure that we'll have great questions and discussions on this panel around those themes.
Well, and I'll just chime in real quick as we move to the next panelist, is that from what I'm hearing we need engineers that actually understand how to do these things in terms of doing the designs and such. And that may be where we come from, as we see there's a hole there that we've got to educate the future engineers to be able to do these things, and to be able to implement. So Jay, tell us about key changes needed in grid access and programs to accelerate smart building technology capabilities.
Well, thanks. Again, I would like to say really thanks to Andreas, CMG, to Texas State for hosting this. This is quite the event, and it's the genius is in the execution in all of this stuff, and this is really executed well. So nice job to everybody. I think the key thing, John, to that question is really to simplify the process by which people can get financial recovery. What's the best way for them to provide the ROI that they need to justify the expenditure in the first place? And so from my standpoint and from Kiwi Power's perspective, what we're trying to do is provide a route to market and a simple but powerful means by which they can monetize all of these assets, whether they're large battery storage, small battery storage, whether it's renewable generation, whether it's large loads, small loads. We think that if you can simplify the process to register those assets and provide the route to market so that there can be an exchange of value, that is one of the most important things to do, because with the increasing penetration of renewable generation, battery storage, the accretion of EVs onto the grid, we see that supplying the energy actually isn't the issue anymore. It's almost like, at least for the large economies, it's not the issue. It's more about that the value is shifting to the flexibility that you can deliver to the grid and less about the energy that you can deliver. So as a result of that, we think that there's going to be a large demand for the ability for building owners, for plant engineers, et cetera, to say, look, I've got this asset here. I'd like to get another way to increase its financial productivity in its downtime, et cetera, just to elevate and improve the financial productivity of that particular asset. And one of the things that's really important to that, to provide this route to market, just happened recently with, as an example, with FERC Order 841, the DC Circuit basically ruled against the state's rights to opt out. And we see that as a watershed moment that is going to help accelerate this shift in value away from the supply and towards flexibility. Because once this kind of gets the ball rolling and we get through a couple of these key things, and the grid and the utilities understand that it's really important to be able to not control everything, and to provide flexibility so that there's more optionality on the grid. We feel that that is a big watershed and a big movement in the market. So if you just consider that Southern and Duke Energy are already realizing some of that, they showed support for regional Southeast Energy Exchange Market. That's very similar to the Western Energy Imbalance Market. We believe that those kinds of things are what's really required to do that. So in terms of what Kiwi Power does, in terms of how we go about making that happen, just show something here very quickly, which is how we go about doing that. So our vision is to simplify distributed energy for global sustainability impact. And the way we do that is where we help people, companies, entities, have the confidence to participate in these energy flexibility markets. How do you provide confidence to do that? Well, you make it simple, you make it transparent, and you make it easy to understand, but powerful. And so our vision is to simplify distributed energy and help people unlock the value that is actually in these distributed energy systems that are fully distributed around the globe. An example that I had is I had a customer discussion, high level, active participants in the US demand response markets. Not at all participating in the ones in Europe. Well, why is that? The complexity of being able to participate in that globally really prevented them from being able to realize the full value in that. So we provide that route to market. We make it simple for companies and entities to participate in that. And we basically are recognized by Navigant as the #1 global VPP provider for execution. Like I said, the genius is in the execution, so we like to quote that a lot. So the core of what we're doing is basically in the cloud. We process all the information. It's real-time information. It's control as well. It applies to a fully mixed asset source of generation, storage, or loads. And as a result, we're able to help people understand how they can actually realize that value. So that's really what I think is important. Simplicity, a route to market, so that people can understand how they can monetize unproductive assets.
Thank you, sir. Appreciate those comments very much. Kind of looking at this maybe from a little different perspective, Scott, you're involved a lot with residential power usage. What do you think that homeowners or just maybe building owners are looking for in a smart structure or a smart home?
So what they're looking for and what they want may be different, and what the grid needs, right? That becomes a whole nother thing. And to go back to something Sunil said, it's like we keep saying 3 years, right? I think that was Sunil that said that, right?
Yeah.
I remember giving a talk on a panel for another group like 6-7 years ago. I think it was Parks Associates or something, where I was talking about how if for residential properties, this stuff needs to fall into a couple of categories. One, it needs to fall into the easy and no-brainer to use and frankly nearly invisible. We used to have to organize upper and lower memory on computers. I'm aging myself. I'm going back to DOS days, right? But we still have all of those things on our computer, all those management programs. In fact, they're way more complex, but the computers do it all for us, right? And so what the homeowners seem to be looking at right now when they're thinking smart buildings and things like that is is a programmable Wi-Fi enabled thermostat. Like we all know them, the Nests of the world, right? They're looking at being able to buy things with an Alexa. They're looking at being able to control lights with an Alexa. My father-in-law was so excited that he got his smart lights working and didn't have to call me. And I was really excited that he didn't have to call me. So these things are smart technologies, and they are home automation technologies, but they're not necessarily something that I would call that we're making these residential structures a grid interactive building, right? To go back to what Pat said sort of in his opening keynote is, you know, he said something like 99% of buildings are dumb. I would say that, you know, that's probably a low estimate, right? We've got, every time that we do programs, and we've done programs for Lincoln Labs, MIT, we've done programs for Eaton, we've done programs for University of Michigan under an RPE contract, we've done programs for all sorts of commercial entities where we do demand response, where like the University of Michigan program funded by RPE is getting homes to follow reg up, reg down signals for pricing signals, right? Well, you know, you think, all right, well, we've got all this smart stuff. Can we do it with what we have, what's commercially available? And we all sit around the table and say, these are the response times that we need. These are the amount of homes that we need to take offline. These are the, you know, when we need to force them online. We need to be able to take air conditioners and turn them off and turn them on. We need to do all these things. And we look at it and go, no, we don't still necessarily have. It's not that it can't be done. The technology is, we can solve the technology problem. But in terms of what the homeowners are going to use and do and put into their house to make these buildings truly grid interactive and truly smart and organize, you know, you can organize large swaths of them to be really useful. It's not there. And we're still not doing it, right? And going back to retrofit old buildings, we have such a huge stock of buildings, is going to be an incredibly difficult challenge. We've got to figure out ways to do this easier, right? We like to solve that problem as much as we can by understanding the data behind it, which is, you know, obviously when you have a hammer, all your problems look like a nail. We're a data collection organization that runs test beds based on this data. So we are always looking at the data. You know, the COVID stuff that we've seen has been a tremendous shift. This is now giving me big concerns long-term with reliability of systems. Air conditioners were running 40% harder in March and April than they historically have been. They're running 8 to 10% harder now than they historically have been. Refrigerators are working 30% harder. Their on-off cycles are way up. So all this means long-term ramifications to warranty periods. Like there's so much that you can do and understand about a building envelope when you have the data behind it. But that stuff needs to all be invisible to the homeowner because they don't know and they don't care. They just want to walk into their house and have their house be nice. And I don't blame them. I want my house to just be nice when I walk into it. And I have a degree in electrical engineering, and I have to end up fixing half these systems and stuff like that. So we still have a bunch of work to do on those respects. And then once we get that all done, I think it's been said a couple of times, the policies to enable that quick and easy and transparent economic feedback. I mean, I've been in this industry for a very long time, and I go look at ERCOT regulations on a regular basis for various things, and it makes me very sad because they're complex. And I can't give a homeowner something along those lines. I have to be, for $20 a month, we're going to do this to your air conditioner for 30 minutes a month. That's it, done, right? Like that's where that conversation has to stop. Homeowners still don't understand that their solar systems are going to keep their houses powered if the power goes out. Homeowners don't understand if they get the battery system that it's only going to be a portion of their home. There's a critical load panel. Like they're like, why isn't my whole house on? It's only the refrigerator. Well, that's all you could afford, right? I mean, like these are conversations that we can't afford to have a clumsy rollout because nobody's going to want to do it.
let me thought
I'll
popped
stop
in-
there.
No, but a thought popped into my head, and so this is going to be kind of like for the panelists to think about in terms of the Q&A session.
Mhm.
Each speaker so far has talked about bringing something, and I think Pat, for a lot of it, was bringing things to the building, bringing things to the infrastructure, or putting something on the infrastructure. But what about making the actual infrastructure structure, the building, the home itself, the 2x4s, the concrete, the steel, whatever, make that smart? Is there something we could be doing? And I'm gonna have to jump to our next panelist, but I just want you guys to kind of think about, what about making the actual piece of infrastructure smart, not by attaching something to it, but putting something in it, to make it smart. So just a thought there.
I'll say real fast, I know we need to be different, but smart is a good idea too. So we'll come back to that.
Okay. So Alper, you're up on deck here, and so Pat talked about integration of the smart technologies. That have a smart building, we got to be able to integrate this smart technology. So what's happening with smart buildings in terms of edge controls and the analytics side and visuals, understanding what's going on? What's happening there?
Yeah, so the industry is definitely moving to IP at this point, and the legacy serial buses are very time consuming. Basically, you have a microcontroller and you have some protocol that is open or that is basically opened up within the last decade. And then you have a gateway, and then you have a supervisor. All the data is moved northbound towards the cloud. And in each step, you change the medium as well as the protocol that you utilize to get the data out from the edge controller, microcontroller. And we're basically changing from microcontroller to microprocessor, and then sending it to another microprocessor to aggregate. This is taking a lot of toll on getting clean data to cloud. It's very time consuming as well. Also, the smart buildings industry is highly siloed. Each microcontroller that the company sells can only be programmed by that company. And this is basically, the analogy would be is that you have a Word document and you open it up in your Windows and you send it to your colleague that has a Mac and they cannot open it. This is the state the smart buildings industry is in, and it is not up to the par of internet technologies that we are using now. Especially for millennials, when they enter into the smart building space, they get really upset why it works that way. So within our company at Anka Labs, we are utilizing open hardwares like BeagleBones. It's actually BeagleBone, Raspberry Pi type of devices are literally being used by the smart buildings industry companies, manufacturing companies. They're utilizing it, but they don't say that they use it. So they hide it behind their closed doors, and they don't want anyone to hear that. So we use BeagleBone kind of device, and we have written an open source project called Project SenStar. It creates world's first hardware agnostic, semantically data typed controls engine. It's basically utilizing all the internet technologies that is available for us. And it will make the millennial programmers happy to enter into our very dinosaur-ish industry. On top of that, we are utilizing an analytics engine, a pattern analytics engine, real-time and historical pattern analytics engine that can connect to a cloud through clustering in a secured way. So there's both way communication security applied for the communication of the data. So we're completely trying to avoid old serial buses that were built in early 70s and 80s. Directly going to IP and analyzing the data at the edge, distributing the data as well. There's a project called Project Haystack. It is pretty much known at this point for its semantic data modeling for Internet of Things. We are leveraging that. And this is basically being leveraged by a lot of the smart buildings industry companies out there. They are basically in the consortium as well. Having that all the way at the edge, the Project Sandstar uses Project Haystack all the way at the controller layer, enables you to simplify value generation. This could be analytics, this could be getting the data northbound, this could be applying artificial intelligence. All these technologies are basically helping us to implement and save energy, and also get the data to the stakeholders which needs to use that for their own applications. So this is the state that we are in at this point.
Do we worry about information overload? You know, with all of the data that can be generated from a smart building or, you know, smart infrastructure, whether it's a home or say a wastewater treatment plant or something like that, can we get overrun by the data, you know, that's coming off of it?
You could get overrun by the data if the data is dirty. If cleaning up a data, within like they call data lakes, is a bigger problem, bigger task than setting up systems from scratch. So within that realm, having the historical data generated where the values are generated, where you're sensing, where you're controlling, you will have clean data. And if you have clean data, then having all the data in there, you might write analytics rules or other things. Maybe in the first pilots, you could utilize it by 40%, but having the data there, I don't see it being a problem as long as the data is clean.
And then you got to find some way to make it visible or understandable to the stakeholder.
That is correct. And having Project Haystack, because it is, so let me explain to you what Project Haystack is. We utilize browsers nowadays, and we are very spoiled by when we open up a google.com in Internet Explorer or Chrome or Firefox, they look all the same. It's because someone else agreed on a semantic data model and made it standardized. So Project Haystack just does that for Internet of Things. So the applications that are written to get the data in reports or visuals layers or do analytics is understandable from human to machine, machine to machine level.
So hey, John, can I make a quick comment on that if you don't mind? If you remember, one of the projects we were trying to launch with Texas State was around exactly that. We found that the amount of data, and I'm sure Scott can weigh in on this from what he's doing, just massive amounts of data, 92.5% of which was meaningless, but needed to be stored. And then the other, the small percentage that you need to notify or act on. We started working on some AI and ML algorithms around how to actually parse that data, and then found very quickly that you run into all the hardware problems of edge compute and having enough horsepower to do that. So those are all related problems, and definitely one of the areas that need some attention and some advancement around that.
So another issue that's a little bit off the technology part of it, but still real important is policy and having a situation where people are going to allow smart infrastructure, and how are you going to manage all of that? So Rebecca, this is in your wheelhouse. You're the policy person, and you've done this for at the government level. So what do you see as the policy challenges here that if we're going to try to incorporate technology into buildings and infrastructure? How are we going to allow this to happen?
Well, policy is huge, and when Sunil asked, why is this taking so long? I wanted to raise my hand and say, wait, I think it's policy. Having spent the majority of my career in government and trying to bring about change in government organizations, the policy is so important. In one agency that I was at, we wanted to allow more online forms, and legislation, the law didn't even allow that, you know, and that seems like such a fundamental thing. Why would anybody be opposed to that? But it simply wasn't allowed in law. And, you know, policy is one thing. To get to good policy takes lots of communication, and you have to have communication with those policymakers. And this is an esteemed panel that I am honored to be on. And the expertise that the rest of you have in these topics is amazing. But that has to be translated into a way that a government leader, someone who's going to be crafting, whether it's a local ordinance or a state or a federal law, they have to be able to understand this information and grasp it and grasp the significance of it. One of the things when I was the director of the driver license division and we were trying to bring about such big change, one of the reasons I think that we were successful in that is because driver license had gotten to such a crisis point that the service that we were providing the customers just was, it wasn't there. It was horrible. And so therefore it was a crisis and we got everybody's attention. But how do we get this to where we don't have to have a crisis to be able to bring about the policy changes that are necessary to be able to make this happen? And when you talk about standardization, it's like, that's wonderful, but then if one city wants to do it differently than another city, they want to go a little farther. So I think standardization is part of that policy, that, you know, shaping policy that's really important. How do we establish standards that are there, but they aren't constraining? So they aren't stifling technology, but they're providing some minimal level of consistency, you know, and I made reference to communicating to policymakers, but there's also the communication to customers. All of this versatility and the customization sounds wonderful, but Scott's right. I just want to walk into my house and have it all work and have it be easy. I don't want to have to know about that. And yet you're going to be offering me so many opportunities to customize and to choose and to decide what kind of power I want and you know, all these different kinds of things. And it's like, I'm trying to feed my kids and make sure that I get their homework done. And, you know, so I think that these are all real challenges, and the communication is just key. Time and time again, the projects that we do at the Institute for Government Innovation, which I should take just a second and explain what that is. We're a center at Texas State that we leverage the talent and resources of the university to provide services and help our clients complete important projects that they don't have the time or sometimes the expertise for. And we give them high value innovative solutions, and we also give students, who are a large majority of our workforce, the opportunity to leverage personal skill development, professional soft skill development, and with their academic learning. And I think that's so much the model of what CEDAR is all about. And I just applaud you, John and Andres and Stan and the rest of the team for having that vision, because those students that are going to be coming out of this program are going to understand the importance of collaboration, the importance of communication, the importance of working across interdisciplinary boundaries. You know, it used to be that so much the study was you came in and you were an engineer and you only talked to engineers and you only studied in the engineering building, and you're really breaking that model by saying, no, we're going to have our new civil technology enhanced engineering students go take GIS classes in the geography department, my home department, or computer science classes, and get out. And having spent the majority of my career in government, That's how you get things done. That's how you're successful, is being able to collaborate and being able to communicate outside of your little silo. And so I think that communication, that policy, you know, there's so many opportunities here to bring that in, that it goes hand in hand with the technology and is what makes it successful. Jay was talking about, let's make this simple. Let's make this a simple process, and we have to keep that in mind. We want all the sophistication and the capability on the technology side, but we have to be able to communicate it in a very simple, understandable fashion for customers and for policymakers.
Excellent. Thank you, Rebecca. Thanks all our panel members for their thoughts here. We have about 15 minutes, and I don't know if we have to have a hard stop at the half hour. I've got a couple.
We don't have a hard stop.
Okay, Andreas, you know, because there's several comments that have come in. Do you want us to run through these, or do you want me to run through them? What do we want?
Go ahead.
So. We had one early on, smart. So I'm just reading what's popped up here, everybody. And so if somebody hears something and they want to chime in, smart buildings and campuses with advanced energy management systems have a significant potential for grid resiliency through pre-programming acceptable lower levels of energy use. The triggering of these lower use levels can be triggered through open ADR. I'm not familiar with that, but the word open, capital ADR. Okay, from the utility where reserve power is required. How do you see the adoption of open ADR in the commercial space advancing?
So we just finished a program with Austin Energy where we had an open ADR interface between Austin Energy, where we were aggregating some residential energy storage units and a vehicle to grid. We think we were the first people in the state of Texas to have a vehicle to grid system. So we had, when all those assets were combined, we had something on the order of about 110 kilowatt hours of energy storage and about 70 kilowatt peak of capacity that we could present to Austin Energy. Open ADR on the surface is a great idea. It's this open standard that is easily extensible to meet the needs and has a bunch of built-in stuff. The amount of extensibility that is there, how much you can change it for your application, is worrisome. Even though we were open ADR compliant, I would never just try hooking, turning our open ADR interface and turning it around and trying to hook it up to something else. I'm not sure with what we ended up with when all was said and done, even though we tried as hard as we could. We had a couple of developers working on it full time for a while. So I think it's a good start. I'm going to steal a line somebody else used a while ago. I'm glad I have it to complain about versus not having anything at all. But I'm not sure it's the ultimate solution in its current form. Whether or not it just gets fixed, sort of like, you know, Sunspec Modbus or any of these other sort of smart inverter, smart storage, any of these other standards that are out there. I'm glad we have them now, but they're still nowhere near where like Wi-Fi is now, or even has been for a very long time, where you just, if you know the password and the access point name, you sync up, right? We're not there. There's a lot more work that has to be done to get any two devices, whether they're aggregated or individual devices, to go talk to each other.
So we've got a lot of questions. So rather than having anybody else comment, I'm going to go to the next one here. So somebody chimed in that a 1 terabyte flash drive is $33 on Amazon. Just Pat as a frame of reference there. So
that's amazing, by the way. I think the last time I bought it was like maybe like $75. I mean, it's half the price. So you can see how fast those technologies move. Wait and see what happens in the AEC industry.
Yep. So there's one here that kind of touches, there's more to the statement, but I want to I'm going to pull one piece out of here, and it's actually right from the start. It says, building systems have been identified as a significant point of entry for cyber attacks. So to the panel, what are your thoughts on this part of smart infrastructure? You know, basically the putting the infrastructure in whatever fashion it might be at risk from a cyber attack. And any thoughts on this? And anybody can chime in.
Does anybody else want to go?
Go ahead, Scott.
Oh, okay. Well, the answer is yes. Like just last week, I ended up figuring out how a Modbus interface was working by using Wireshark on an unencrypted TCP/IP connection. And if I'm doing that, and I'm not very good at those sorts of network level things, if I'm able to do that, that's bad, right? Like that's really bad. Right now, I don't worry about it on a building scale as much as I think as some people. I think a lot of folks are making it a bigger issue now than it is, because frankly, the grid has such inertia. Like if you're talking about grid stability and stuff like that, I don't think you can get access to enough stuff unless you're actually attacking utility resources. Like even if you got the 20 power walls that Bandera Electric Co-op has in action and all made them charge and discharge, right? Like that's not going to do anything. It might confuse the homeowner, might make their bill go up, but it's really not going to do anything from a grid stability issue. But when these things sort of take off and get to the larger scale, then yeah, it's something we have to worry about.
You know, I actually think it's more. I mean, I agree with you, Scott, that for the most part, probably not going to be able to take the entire country down through any of this stuff. However, when you're talking about how do you make it more marketable, how do you accelerate its adoption, everybody's concerned about it because they don't know anything about it. So you almost have to address it just because of that factor alone.
From the perception factor, not the technology. Yes. Yes.
Yeah.
Anybody else want to comment?
Yeah. Hey, John, I was just going to add that, you know, it took a while. If you look at like, you know, just radio communications in general today, and, you know, the AES digital encryption standards are pretty solid, you know, 128, 192, 256 for even very hardened communication protocols. And I can remember even a couple of years ago, people, I'm not going to do anything on a radio. You know, someone can intercept it and crack it, but AES is pretty strong these days. And even, you know, even if you go beyond that into the RSA and the way more advanced encryption technologies, they're pretty solid. But I think both folks are right that there's still a perception, and there's probably some usership and learning cycles that are going to have to go into this to help secure, you know, people's minds and how to use this. You know, same thing as Wi-Fi and all the, you know, low energy protocols, and every single one of them has gone through sort of this cycle of, you know, risk and assessment and scarce, and then finally it's okay, and now it's ubiquitous, right? And it's pretty secure.
I would like to add one comment on that. I think the defenses built around these technologies needs to be holistic. It would start from hardware. Every chip that you use needs to be checked, and then you would go into operating system if you have secured boot or not. If you have an application that has a hole, do you have a patching mechanism? Also, the communication from that software needs to be encrypted, as Pat said. The physical access to the device needs to be have rules on it. And the final part is that the training for the users. I think the humans are the weakest link on security. And the one part is that the IT/OT segregation, internet technologies and operational technologies, networks needs to be segregated physically or with virtual lens. These things are must, and we are as strong as our weakest link.
Hey, sorry, let me jump in again too. An interesting comment is even back in the days when I was at Flextronics, we saw that a lot of security and violations actually happened in the factory. You know, when you're doing things like, you know, loading boot code or gold code on devices, In a factory environment, you have to be very careful there. And I completely agree with Alp that could even be one of the weakest links when you start to manufacture, devices or, connection technologies or whatever in the factory environment. You have to secure that. And companies like Flextronics have put in very sophisticated protocols, to sort of separate that from the normal, production or manufacturing environment. That's really been a big concern and something that all the big OEMs are addressing.
There's a lot of comments in the chat. So I'm going to ask, I asked you guys that one question before, but I'm going to, about making the building smart, but I ask a different one here. So I am an EV owner. It took me doing a life cycle cost analysis to convince my wife that being an EV owner made sense. So for all of this, smart building, smart infrastructure, things for home, how do we convince, owners? How do we convince developers? The economic value of implementing the, so maybe, not for you guys to give away your trade secrets, but how do you convince people to take advantage of what you guys are offering?
So it's interesting. We see a divide. It falls basically into two buckets, right? There's the bucket that you just described where somebody has done this cost analysis. Like when Pecan Street got started, the city of Austin Energy's rebates for solar were fantastic. We were offering a rebate. There was a tax credit available. And somebody in the Miller neighborhood had a background in finance, and he ran all the numbers and basically advertised it to the neighborhood as, hey, if you get the Pecan Street rebate, the Austin Energy rebate, and the tax credits, your payback period is 2.5 to 3 years. And at the time, that was an unheard of solar payback rate. It's still unheard of, right? I mean, that's like we gave people a lot of money. And then there's this, so there's that bucket, but that is a special case. There's not a lot of folks that do what you did, right? Mm-hmm. There's not a lot of folks that want to take the time. The other bucket is the, do I want it or think I need it? And can I afford it, or do I think I can afford it, right? So if the answer to those questions is yes in the right order, I think I need it and I think I can afford it, whether or not they can actually afford it, doesn't matter. Doesn't matter, they're gonna buy it, right? We have, my parents fall into that bucket. They live in Austin. Their experience with Hurricane Ike was so bad in Houston that when they moved to Austin, and my dad can afford it. It's not that he thinks he can afford it. He bought a 20 kilowatt Kohler backup generator to run the whole house if the power goes out. It runs a 15-minute service run every week. It has been used in the 5 years that he's lived here for about half an hour. And so, and when his power went out and the generator kicked in and the house came back online, I got a call. I have the generator, it's working, right? He was so happy. And to him, it was worth it.
Alper, how about you? How do you convince people to get involved with your company?
For the grid level systems, we are more in the smart building control space, but I would position it as for resiliency. If you're a company and I wouldn't even look at the numbers of the cost of implementing these technologies. The cost would be for the resiliency. How much does it cost for your employees to go back to their homes because your fan is not running or the electricity went out? So if we look at it from the resiliency level, having these systems, solar panel, cars charging the buildings, once we have these technologies where we can transfer the electrons to the direction that we need to have more resilient businesses, then I think the dollar amount that you save or if you spend what you save is a lot more than what you spend, regardless of the cost of power.
So do you find it challenging to get people to understand the benefits, or do they catch on fairly quickly?
I think I mean, once you explain anything regarding to security and resiliency, does catch up. It really triggers for them to make purchases quickly. But on the resiliency side, I think there's technologies. We have solar panels on the roof, but when does it need to charge the battery? How does it predict to charge? How is the building is using it? So these technologies are not ripened up enough yet to have our optimal resiliency for the technologies that they would purchase. So I'm hopeful that within the next decade, we will have better technologies and the costs will come down overall.
Well, history or the trends would suggest that that should be the case. We'll have to see. Jay, I'm going to ask you this question. I'm a kid. You know, I was born 1959. Actually, Pat and I just both recently turned 61, just a few days ago. And I remember the predictions, and I've said this to my family all the time. I remember seeing on TV, someday you're going to be able to order groceries from your refrigerator and this kind of thing. So and here it is. I mean, we can do it today. I mean, and that was 45, 50 years ago when people were predicting stuff that, may have taken that time, but it's happened. What do you see? What's in your crystal ball that somebody could hear today and go, oh, man, whatever the amount of time it is that it might be, that actually did come to be. Right now it's not out there, but it did come to be. Is there any, what's swirled around in your brain of what we might do in the future?
Well, I think outside of going to Mars and having people living on Mars, I mean, that seems to be the whole SpaceX thing is just incredible with what's going on. And to think that that's just one of the companies that he's got, that's just like, that's pretty amazing. But maybe that's a better question for Elon than for me, but I'll just take.
But I mean, in your world, in the world that you live and work, what can you imagine, or what kind of gets your mind going of what the future could possibly be?
I really think that I'm not big on blockchain right now, but I really think that that whole movement, whatever that is in its fullest completion, I think that is probably where things are going. I'm not so sure that it's any more than say 10, 15 years away. Maybe even closer than that. I don't know, but I just think that that's probably the biggest thing that I see on the horizon, where
it's a pretty abstract thing. I mean, it's hard to. I mean, it's kind of like electricity. It's hard to put your fingers.
It's very hard. Yeah, but I do think that that's probably the thing that'll get condensed.
So there's a comment here, and I have to agree with this, that we were promised flying cars. I'd have to agree with that's one of those things that as a kid that was along.
I've seen I-35. Are you sure you want that?
Huh?
I've seen I-35.
Oh yeah. Around here, yeah. I'll tell you, the EV I own helps the ride on 35. So.
Are you saying 35 recently?
Oh, I love
COVID,
driving on.
COVID has done wonders for I-35.
Yep. So we are over time, but I'll ask this one if anybody wants to chime in. How do you see us actually making structures smart? That the actual physical building or whatever the infrastructure asset is, we can have smart technologies that bring power to the building. We can attach things to treatment facilities or to water towers or whatever. But can you guys imagine or think, or if you had any thoughts about actually making the infrastructure itself smart? Pat, I think you've had some things that, you know, detecting people.
Yeah. So I do have a few thoughts on that. So I think largely in the near term, it's still going to be devices that you attach to materials, because it's very difficult to make materials themselves. You think of wood, you know, can I turn wood cells into a communication antenna? I don't know, maybe, you know, concrete, what do you do with that? There is an area where there's tons of investment and interesting technology in Windows. You know, the electrochromatic layers that allow you to, you know, darken, you know, reflect light or pass light through, which is a great energy control asset. And, you know, once you start looking at some of the layers in there, they look very similar to, you know, the ITO touch layers that are fully enabled in tablets and cell phones and things like that today. And we've even been talking about, well, why can't I make a window, a TV also, right? You know, I can address cells on you know, thin films and cause them to do RGB things and stuff like that. So windows are really interesting, and inside of the building structure, how you route and consume the power and the control elements, you know, distributed, you know, through a framework of materials. It could be aluminum or steel or wood or hybrid combination of that, is probably, to me, the cutting edge. So I still think it'll be a lot of devices and maybe technologies that get embedded in materials. And then the materials themselves that you build with, I think we've got lots of physics runway left to figure out how to sort of enable that. It's just my view of things.
Sure. No, I appreciate that. Well, and we are over our time now, so you should wrap things up. So let me thank all of our panel members for their comments here this afternoon. Pat, for your keynote. I thought that this was excellent information. What I think I heard a lot of is simplicity, simplicity, simplicity. You know, that's going to be a big part of it, and basically the plug and play kind of. And I think that ties into the simplicity, but not having to worry about how the system functions. But I'm going to throw in my own 2 cents here, is that, you know, we're here in the civil engineering program at Texas State, looking at educating the next generation of engineers, specifically civil engineers, to design infrastructure that will accommodate or will be smart. So the application of technology to infrastructure is the focus of our program from beginning to end. And we find it to be highly unique. So, you know, I hope that we're going to be able to contribute to all of this through the education of the next generation of civil engineers. So Andreas, do you want to come in and wrap things up for us here?
Guys, that was fantastic. I could have not, I mean, it was like, whoa, lots of interaction. Great job. I'm ecstatic that you're all connecting. I want you all to connect electronically, become best friends. We are in the middle of this big transformation, what we're doing at Texas State and CMG in collaboration with all of you. I mean, we are driving the bus here. Stay tuned for follow-ups. Thank you. Delighted to have you. Thank you for everything. Congratulations. Great job.
Thank you.
Thanks,
Thank you for inviting us.
Bye, guys.
Everybody's time, and thanks for everybody that attended.